let's graph this rational function. To do that, the first thing we want to do is factor the numerator and denominator, because we need to see if anything cancels out. Because if it cancels out, it won't be a vertical asymptote or an x-intercept. It'll be a hole. So we got to make sure that's not going to happen. So the numerator, if I factor this, x squared would be x times x. 2 can only be 2 times 1. Inner plus outer equals middle. Inner, right here, I have 2x. Outer, I have 1x. I'm trying to get a middle of 1x, so I need a positive 2 and a negative 1. So that's plus and minus. And that does give me negative 2 when you multiply, so that's good. Now I'm going to factor the denominator in the same way. X squared would be x times x. 3 can only be 3 times 1. Inner plus outer equals middle. Inner I have 3x, outer I have 1x. I'm trying to get negative 4 middle. So that means both of these would have to be negative, so both of these would have to be negative. Now, sure enough, I see a factor that's going to cancel. So normally an x minus 1 in the denominator would mean, oh, I'm going to have a vertical asymptote of x equals 1 and 3, but I'll get to that later. But no, since this cancels out, it's not going to be a vertical asymptote. It's going to be a hole. So I'm going to have a hole at an x value of 1. Okay, and so normally I'd have an x-intercept at 1 because of the numerator. But again, because it cancels out, it will not be an x-intercept. It will be a hole at 1. So, you know, if I set x minus 1 equal to 0 and solve, I get x equals 1. That's why I'm saying 1. But we need to know what the y value of that hole will be. So, to find the y value, I'm going to take what's left of the function and deal with that for the rest of the problem. So the function now has become x plus 2 over x minus 3. So I can really deal with that for the rest of this time. So to find the y value, I'm going to use my simplified function and put that in my calculator. Okay, so in the numerator I'm going to put x plus 2. In the denominator I will have x minus 3. Okay, I'm just going to stay in Ask X mode. Okay, so let me just clear this out. So I want to know what's happening at 1. So I put in 1. So I've got negative 3 over 2. So that means I have a hole at 1 comma negative 3 over 2. Okay, now negative 3 over 2 is the same thing as negative 1.5. So let's go ahead and graph that. I'm going to snag this. Alright, because that looks like a hole. So I have a hole at 1 comma negative 1.5. So that would be right about here. So there's my hole. Now I can go ahead and do the rest of the problem. So let's see. Let's talk about the x-intercept now. For the x-intercept, I can set the numerator equal to 0 on a problem like this. So I will do x plus 2 equals 0. That will give me x equals negative 2. So that means I'm going to have an x-intercept of negative 2 comma 0. Okay, so I'll use this for my x-intercept. So I've got negative 2 comma 0 is right about there. Now I'm going to find my y-intercept and graph that. For the y-intercept, I can just use my calculator. So it's already typed in. So the y-intercept is always going to be 0 comma something. So I'll just put in the 0. And I've got negative 2/3. Okay, so 0 comma negative 2/3. That's 0 comma negative 0.6 repeating. Okay, so I'm going to graph that. Alright, so 0 comma negative 2/3 is going to be right about there. Okay, now let's talk vertical and horizontal asymptotes. Gotta get this stuff out of the way. Alright, let's talk vertical asymptote. You can get the vertical asymptote by setting the denominator equal to 0. So if I set x minus 3 equal to 0, I will get x equals 3. So that's my vertical asymptote. Okay, so x equals 3 is right about here. Now it seems to be behind that line. Alright, there we go. Now, so that's my vertical asymptote. How about the horizontal asymptote? Well, the horizontal asymptote depends on the degree of the numerator and denominator. Since the degrees are the same, then that's when we use the leading coefficient, so 1 over 1. So y equals 1 will be in my horizontal asymptote. Okay, so y equals 1 will be right about here. So there are my asymptotes. So I've got my asymptotes and my x and y intercept. So now I just need to plot a few more points so I can get a better picture of what the graph is going to look like. Now every vertical asymptote gives me 4 points that I need to plot. So I had a vertical asymptote of 3, of x equals 3. So imagine 3 on a number line. So 3 would be right here. So I'm going to get 2 values by going to the left and to the right of this. So to the left of 3 would be, you know what, let me change colors. To the left of 3 would be 2. To the right of 3 would be 4. But I also want the point halfway between these. So to the left, between 2 and 3 would be 2.5. Between 3 and 4 would be 3.5. So these are the 4 numbers I need, these pink numbers. Okay, so let's do it. So I'm going to use my calculator to help me out. Whoops. Alright, I meant to hit delete. Okay, so I'm going to do 2 and 2.5. Okay, so I've got 2 comma negative 4. And I've got 2.5 comma negative 9. Alright, now I need to do 3.5 and 4. So that's 11 and 6. Okay. And 6. Alright, so my points are looking something like this. So this is plenty to show me what the graph is going to look like, folks. So obviously it's going to be approaching the asymptotes, and then it's going to be passing through each of these points as it does so. Okay, over here it's got to be passing through these points on its way approaching the asymptote. Okay, this keeps disappearing. I give up if that disappears. So this is what my graph is going to look like. Now I'm looking for a match. So I need a graph that's, it should be in the lower left and the upper right. Okay, this is in the lower left and the upper right, but this doesn't even have a horizontal asymptote, so I know that's not going to be it. Can't be B. Alright, D is the only one that's even close, so I'm betting that D is the answer, but let's look a little more closely. Vertical asymptote at 3, horizontal asymptote at 1. Okay, yep, vertical asymptote at 3, horizontal asymptote at 1. And we have a hole at 1, comma, negative 1.5. Okay, so that looks like about right. So the answer is in fact D.